Hello, my name is Brian Shack, and I'm an associate instructor teaching C211 Introduction to Computer Science. This screencast will explain how to design and use the data definitions for enumerations and structures. So let's get started. As you recall from Lab 2, every function that you design in this class requires following the design recipe. The preface of how to design programs explains each of the steps of the design recipe. You have already designed functions that will have a signature, purpose statement, and tests, aka check expects. Lab 3 will focus on data definitions. In your function signatures, you have used built-in data types such as booleans, e.g. #true and #false, numbers, strings, aka text, and images. The beginning student language has additional built-in data types that you will see in later labs. You can also define your own data types using data definitions. The data definitions can have any name that you want, but you should try to choose a meaningful name so that other people will understand it. And after your data definition, you can use your new data type in function signatures or even other data definitions. Enumerations. One kind of data definition is called an enumeration. An enumeration lists each of the possible values. For example, consider the following department enumeration. A department is one of biology, business, computer science, or English. It is in a comment because it is interpreted by other programmers, not by the beginning student language. Some other programming languages, which you will learn in other classes, will read and enforce the enumeration, so it will not be in a comment. Using the data definition of a department, we can define several examples. Define Alice's department, computer science. Define Bob's department, business. Define Charlie's department, English. Now we can access the values of those examples. Alice's department, computer science, Bob's department, business, Charlie's department, English. If you try to define an example which is not one of the possible values of the enumeration, you will not get an error message because the beginning student language does not enforce the enumeration, but it will still be incorrect. Define Dan's department, geology, incorrect. Define Edna's department, architecture, incorrect. From the data definition, you can then design a template. A template is a function with parts missing. The missing parts are replaced with an ellipsis, aka ... like this. Examine the following template for processing a department. Process department, arrow ... define process department, cond, department, biology, department, business, department, computer science, department, English, Check expect, process, department, biology, Check expect, process, department, business, check expect, process, department, computer science, check, expect, process, department, English, Notice that the data definition, the template, and the tests have the same 4 cases: biology, business, computer science, and English. The beginning student language can check the syntax of the template, but since it is incomplete, the beginning student language cannot run it. Finally, we can use the template to design a function by filling in the ellipses. Consider the following function which calculates the salary for each department. Calculate salary, department, arrow, number, calculates the salary for the given department. Define, calculate salary, department, cond, equal, department, biology, 100,000. Equal, department, business, 110,000. Equal, department, computer science, 120,000. Equal, department, English, 130,000. Check, expect, calculate salary, biology, 100,000. Check, expect, calculate salary, business, 110,000. Check, expect, calculate salary, computer science, 120,000. Check, expect, calculate salary, English, 130,000. Another kind of data definition is called a structure. A structure composes several data types into a single new data type. Consider the following vehicle structure, which contains 3 fields: company, model, and year. A vehicle is a structure. Make vehicle, string, string, number. Define struct, vehicle, company, model, year. Notice that the second line has the types of each field, and the third line has the names of each field. Don't get this backwards. The second line is a comment, so the beginning student language does not enforce the types of the fields. But the third line is not a comment, so the beginning student language does enforce how many fields and what they are called. Using the data definition of a vehicle, we can define the following 3 examples of vehicles. Define Brian's vehicle, make vehicle, Toyota Camry 2005. Define Mark's vehicle, make vehicle, Ford F-150, Flairside 1998. Define Rachel's vehicle, make vehicle, Chrysler PT Cruiser 2005. In the Interactions pane, we can retrieve the examples of the vehicles that we defined. Brian's vehicle, make vehicle Toyota Camry 2005. Mark's vehicle, make vehicle Ford F-150 Flairside 1998. Rachel's vehicle, Chrysler PT Cruiser 2005. The data definitions provide the following 5 courtesy functions for the vehicle structure. 1. make vehicle, string, string, number, arrow, vehicle, which is a constructor. 2, vehicle, any, arrow, boolean, which is a predicate. 3, vehicle company, vehicle, arrow, string, which is an accessor. 4, vehicle model, vehicle, arrow, string, which is an accessor. And 5, vehicle, arrow, year, vehicle, string, which is an accessor. The constructor makes a new vehicle, the predicate determines whether a vehicle is a vehicle, and each accessor accesses the field of the vehicle. If a structure has more or less fields, then it will have more or less accessor functions. So now let's use those courtesy functions that we just defined. Vehicle, Brian's vehicle, true. Vehicle, Mark's vehicle, true. Vehicle, geology, false. Geology is not a vehicle. Vehicle company, Rachel's vehicle, Chrysler. Vehicle company, Rachel's vehicle. PT Cruiser. Vehicle year, Rachel's vehicle, 2005. From the data definition of a vehicle structure, we can design the following template to process vehicles. Process vehicle, vehicle, arrow, define, process vehicle, vehicle, vehicle company, vehicle, vehicle model, vehicle, vehicle year, vehicle, check expect, process vehicle, Brian's vehicle, Notice that the template for an enumeration has a conditional, but the template for a structure does not. So up here, process department, the template has a conditional, but down here, process vehicle, the template does not. A department is one of the values biology, business, computer science, or English, but a vehicle is all of the fields, company, model, and year. And finally, from the template for a vehicle structure, we can fill in the ellipses to design a function, upgrade vehicle, which upgrades the vehicle by 3 years. Upgrade vehicle, vehicle, arrow, vehicle, upgrades the given vehicle by 3 years. Define, upgrade vehicle, vehicle, make vehicle, vehicle company, vehicle, vehicle model, vehicle, plus vehicle year, vehicle, 3. Check expect, upgrade vehicle, Brian's vehicle, make vehicle, Toyota Camry 2008. So that's all I have for how to define and use the data definitions for enumerations and structures. Thanks for joining me.